authorized technical representative for peroxicam in Italy. And today, on behalf of the entire company, I would like to present an innovative technologies for the treatment of contaminated soils and groundwater with heavy metal. Before jumping into the core of the presentation, I would like to share with you just a few words on peroxicam. In particular, peroxicam has been a leader in the remediation industry since the early 80s, launching every year innovative technologies for the treatment of contaminated soil and groundwater. In this slide, we can see the distribution of the main offices, warehousing, and main technical managers around the globe. You can see how we cover most of the world. Peroxicam has been in the remediation market for a long time, supporting clients from the start to the finish in order to meet clients' requests and needs, and at the same time we provide feasibility studies at our independent laboratory in the US in order to meet site-specific requests. Generally speaking, our approach is to ask clients to share basic information, site-basic information, such as contaminant information, geochemical data, hydrogeologic information, in order to let us come up with a budgetary estimation and preliminary study. Peroxicam technologies can be summarized in 6 main categories: technologies for in situ chemical oxidation, technologies for in situ chemical reduction, technologies for aerobic bioremediation, technologies for biogeochemical treatment, technologies for metals remediation, and technologies for enhanced reductive degradation. In particular, this presentation will focus on technologies for the metal remediation. And because of this wide and deep portfolio, we are able to provide customer site-specific solution in order to meet their needs. And for example, timing, street cleanup goals, and other possible site constraints. Metafix is a new Metafix reagent, are a new family of reagents designed to treat heavy metals in soils and groundwater using mainly chemical reduction, precipitation, and adsorption. The Metafix reagent don't really rely on in situ biologic sulfate reduction or carbon metabolism, so they are not inhibited by possible high toxicity. For example, in case of alkalinity, high contamination concentration, acidity. The reagents are mainly composed by ZDI, iron sulfides, iron oxides, alkaline carbonate, and activated carbon. The main principle of Metafix, once injected in the surfaces, or once applied in the surfaces, is about the conversion of heavy metals in aqueous phase to a low solubility mineral precipitate. And lastly, because a Metafix reagent is able to generate strong reducing condition, is able to treat heavy metals and permanent solvents. So we can easily apply Metafix for treating mixed plume. About some application characteristics of Metafix. Metafix can be applied at low dosage rates, usually between 1% and 6% by weight for soil and less than 1% by weight for groundwater. It can easily apply using traditional methods such as soil mixing, trenching, direct push injection, hydraulic or pneumatic fracturing, and the standard metafix concentration is usually between 40 and 70% solids. In this slide we can see a summary of the main metafix removal mechanisms depending on the different methods. As I said, the main treatment principle of metafix is about the formation of heavy metal sulfides that are very stable and insoluble in a wide pH range compared to the respective heavy metals hydroxide. For example, we can see how the heavy metal sulfides are very insoluble and stable over a wide pH range, and in particular over the natural pH range. It's a little bit different for chromium. In fact, the reduction of this chromium by the metafix is basically on the transformation from Chrome 6 to Chrome 3 has iron chrome oxyhydroxide precipitate that is very insoluble for around less than 5 ppb over a wide pH range. The first case study that I'm going to show is about the application of the metafix technologies as PRP trench in a historical contaminated site. We can see in the picture the main source area. So the treatment strategy was about the excavation of the source area and the application of a metafix PRP barrier at the downstream boundary of the excavation in order to stop and to prevent the migration of the contaminants, of the heavy metals outside the site. In particular, the contaminants were alumine, arsenic, and copper. We ran a preliminary bench test laboratory studies in order to find out the best site-specific formulation and the respective dosage. In particular, we found a 6% by weight dosage. In this picture, we can see some application cases, in particular the installation of the metafix PRP trench at the downstream boundary of the site, using a traditional method such a traditional tools. And here are the results. We got the cleanup goals in less than 12 months from the application for all the contaminants, so for alumine, arsenic, and copper. The second case study is about the application in an active facility plant in the north of Italy, where a Chrome 6 contamination has been discovered in the Vadose zone. In the map we can see the main contaminated area, and the contamination discovered was between 2 and 5 meters below ground level. We applied for a total of approximately 100 to 20 square meters. We applied metafix through 18 injection points, approximately 1,000 kilograms per point, and we can see the results before and after the application. We just take soil sample in the injection area for testing the treatment efficiency, reaching the cleanup goals of 15 milligrams per kilogram for soil. Third case study is about the treatment of excavated soil contaminated with leads. We ran a preliminary laboratory test for determining dosage. We used a 6% by weight dosage, and we apply metafix to the excavated soil, reaching the cleanup goals. Approximately the treatment time was 7 days. The last case study is another application in Italy. This is another active facility plant in the south of Italy with a historical contamination in the shallow aquifer with heavy metals and some chlorinated solvents, in particular mercury, copper, nickel, dichlorpropane, and some TCD. First phase was about, again, treatability testing in order to come up with a site-specific dosage and formulation. Second phase was about a pilot. We applied, the pilot area was in one of the main contaminated area in the shallow aquifer between 9 and 11 meters. We see in the picture the pilot area, and we apply approximately 1,200 kilograms of metafix per point in a 55% dilution. And here the results. In less than 6 months, we reached the cleanup goals for mercury, nickel, and in particular for dichlorpropane with a rapid decay of the concentration. So, in conclusion, the metafix family reagents are very cost-effective and competitive methodology for the treatment of heavy metals contamination in soil and groundwater or mixed plume. They are independent from possible alkalinity or acidity or toxicity of the aquifer and the soil, and they are the reagents are long-lasting ones. In fact, the longevity could be up to 10 years with just an application. Thank you for the attention and for any questions.